I had to pause the video and then had to like write sorry this all these stuffs because it's going to take time to write all of them. But just know that this is what we took. Those high values we're trying to like scale it. We're trying to like scale. We took aggressiveness and visual ability. Hope you get the concept. Okay, so we now have to now scale all these columns. The columns I want to scale. So we now loop through it for call in columns. Okay, we now call the data taking the find the particular column, and we'll add the plus. That is, we're assigning a new column. Now call the main mass what we imported. That's main mass. Sorry. Then we call the data column. So basically, what I think this is very self-explanatory. We're trying to create a new column that will have a normalized value or a scaled value value in it. So we use it and we scale it, we scale it. We scale it basically with this min mass scale. I think it's going to put it in the range of 0 to 1. So we're going to run this. Hopefully we'll get no error. Okay, so let's now check out the data and see whether it worked. So you can see it has created a new column, like I said. Create a new column. Are you seeing what I'm talking about? So so it worked. So now what I have to do, we have to now like drop this column. Because they're not important again, we need to drop them. So let me just create this one. This is just continuous. So call the data dot drop the columns, these columns that we have replaced already. Now put an as is equals to 1. Okay, and hopefully we let us check whether it worked. Okay, you can see that the column have been dropped and we have our scale data. You can see that now it's more normalized. So the weight of every data point is now more emphasized. Weight versus emphasized, I would say. So now the next thing we have to do now is we have to create our cluster. Let's enter into the k-means algorithm proper. So let's write this: creating and exploring the clusters. Let's write the write up because we are dealing with 3 forwards. That is what our assignment was. Just find a place for those 3 forwards. We will create 3 clusters. For each of them. So that's basically what we're going to do. Then we have to import the k-means algorithm. Like, we know how the algorithm works. First of all, this way it works is you type it okay, create from 3 clusters. It then randomly places the different data points at different clusters, and as it does an iteration. So as it's combining the equidistant distance, use equidistant distance to find how far it is from a particular cluster. So okay, let me start afresh again. the k-means, when you initiate it, what it does, it creates, like you say, okay, now create for me 3 clusters. Now it creates that those 3 clusters and randomly assigns a pivot to each of those clusters. For example, it creates you say it creates 1 to 3 as a cluster, 4 to 6 as a cluster, 7 to 8 as a cluster. Now it will now take 2 for the first cluster, which is, I can write this down so you can really understand what I mean. Let's say this is the first cluster, 1, 2. This is the second cluster. Let's say this is the first cluster, 1, 3. This is the second cluster, 4, 6. This is the third cluster, which is 8, 10. So first of all, it's going to randomly assign this variable based on what it has, data it has, to assign it, and then it will now assign a pivot. So it chooses the pivot as 1.5. Yeah, that's the pivot. It uses this pivot. Okay, it's going to come to pivot very soon. Let us assign the pivot first of all. Let's say it chooses 5 as a pivot here, and then it chooses 9 as a pivot here. So now it's going to with this pivot, it's going to use this pivot based on the input data is coming. As data is coming, it's going to use this pivot as the allowance. It will say if this item is 4 times greater than, for example, 4 times greater than the pivot, then assign to the second cluster. It has to be equal to the second cluster's pivot. If this, I did for the 70, if it's greater than 5 or less than 5 at a particular threshold, it transfers to the third cluster. So it does this iteratively. Let's say, example, now a number is coming, 2 is coming. Now it will assign this to this cluster. Its cluster. I will say 4 is coming. Now 4 is, it will be, if you do the equator distance based on 1.4 and 1.5, is a little bit bigger than 1.5, so you will assign to the second cluster. And now it now alters the pivot. This pivot is 1.5. So now, based on the data is having that has been added to the cluster, it's not going to be adjusting the pivot. So I really think I've been more intuitive explaining this for you. But like, do it real life. I go in the SQL does it for us already, but that's what it does in the background. It assigns a pivot, and based on the pivot, it computes the equidistant distance. If it's far enough, it assigns to the next cluster, and then it also adjusts the pivot based on the variables that are there. It does this iteratively for all the data. So let us do the abstract the k-means algorithm. So sklearn star import k-means. That's capital. It's one of the popular constant algorithm that we have. So let us now call our k-means model. I will call the k-means, like I said, the cluster we're having is 3. And like I said, it randomly chooses stuff, so we have to put a random to make it reproducible. Let's put a random state. So then you can put any value you want to put. You can put 31, 34. You just stick to 1. Then the distances, which is like I said, is going to return the distances from each cluster. Yes, for each data point for each player, it's going to return since we have 3 clusters, it's going to return the distance from each particular cluster. For example, cluster 1 is going to get the equidistant distance from it based on the pivot. The pivot is what is kind of helping to calculate the equidistant distance. So we'll see this. So put distances. That's not the way to spell distances. K-means model dot fit transform we're calling because we're calling this the chemistry. We're using it now to make our prediction, or we call it trying to explore the data. So it is data, like we said, we're not using those columns. We're using only those columns that we feel like has data about it. So we're not using those pair name, crop and all of that. So we start this is used to select and slice an array, a data, a pandas data frame, like I've explained earlier on. So we choose from four, which is like we said, if I can show you this data again. Data, let me put it again so I will show you what I mean. Yeah, okay, we're starting from here, which is the fourth index. Okay, so this then we will now print the distances. How the distance is based on how far it is from which pivot and all of that. What's the problem? I made some mistake. Okay, sorry. You always have some errors in your code, don't worry. From skrin.cluster. I think that's some dot cluster. I'm making some errors today. Just forgive me for that, please. Okay, so we can see what he printed. So now for this first data, which should be, I think is our first data. Let us print this data so we can we have a flow of what we meant. So we have Jamie Vardy, the first. That's Jamie Vardy is the first one. So what I was saying that from the first cluster, the distance between it and the first cluster is 0.3. So that means it is closer to the first cluster than the second cluster and the third cluster. The second one is we say Sergio Aguero. Sergio Aguero is closer to the second cluster than the first cluster based on the pivot. So this appropriates all of them. So we can see that these three forwards that we are trying to find a person for, they are distinct. Let's example, the third one is of Oliver Giroud. Oliver Giroud belongs to the last cluster. Like anybody that any player here that finds himself on the last cluster, it's an ideal replacement for Oliver Giroud. So the second one is Aguero belongs to the second cluster. So any player that's under the second cluster is an ideal replacement for Sergio Aguero. Then same for Jamie Vardy, the first one. So it is closer to the first cluster. So the distance is 0.36. So anybody that belongs here is a replacement for Jamie Vardy. So this is now intuitive for us now to understand how the K-means does. So we're going to now, like, first of all kind of categorize it. It since we have found out that we have created a cluster and found out that the zeros cluster belongs to Jamie Vardy. The second cluster belongs to Aguero, and the third cluster belongs to Oliver Giroud. So let us now find the players that belongs to those clusters. So let us find the ideal replacement. Okay. So the first one, let's start with Jamie Vardy. Is the first cluster. Let's say Jamie Vardy. I think that's the spelling of his name. Ideal. Let's put it replacement. So we'll just put it. We call the data. Call the data, and I will put